Parakeet AI is an AI job interview assistant that gives you answers and solutions to every coding problem on your job interview.
Hey everyone, welcome back to Take You Forward. We will be starting with a new pattern of DP, which is the partition DP. And this is kind of like a tough pattern. It's a tough pattern. It isn't as easy as the previous patterns where we have done 1 DP, we have done 2 DP, we have done DP on grids, DP on subsequences, and you, after doing all the problems on those patterns, you are pretty much comfortable. Similarly, I can guarantee you, once you have solved all the problems that I will do on partition DP, you'll be very, very comfortable on partition DP. Generally, all the other creators have just solved MCM or probably the Boolean parenthesis problem and they would have stopped. But over here, I will be solving I think 4 or 5 or 6 problems on this particular partition DP so that this gets right into your head. Okay, so let's understand what's this partition DP all about. So generally, in all the problems where you'll be said to solve a problem in a particular way, remember this: solve a problem in a pattern. Now, what is the pattern? For example, whenever you do mathematical calculations, right? So assume you have been given something like 1 plus 2 plus 3 into 5, right? But if you put it like this, then the answer is different. But if you put it like this, then the answer is different. Don't you agree? So whenever you find questions similar to these, like if you solve a particular pattern, like in a particular way, you get some other answer, or you solve in some other particular way, you get some other answer. That's when you can relate that to partition DP. Remember this: whenever there are multiple ways to solve, and probably they will ask you to find the best possible way, that's when you relate the problem to partition DP. So generally, how will you solve a partition DP problem? So as of now, I did tell you some rules for the dynamic programming, but for partition DP, there will be a different set of rules. Let's understand. So generally, in all the problems, you will have an array. In almost all the problems, you will have an array. And as you saw over here, you solve this portion at first, and then this portion, or you can solve this portion at first, or this portion. So similarly, in partition DP problems, you'll be given an entire array, and you will have to solve it probably this portion at first and this portion, or probably it can be you have to solve this portion at first or this portion, or probably you will have to solve this portion at first and this portion. So you will have to try out given an entire array, and generally the starting point will be known as the I, and this will be the ending point. Okay, and the partitions can be this where you solve this and this. So or the partition can be this where you can solve this and this, or the partition can be this where you can solve this and this. So there can be a lot of partitions. Partition key can be here, partition key can be here, partition key can be here, partition key can be here. It can be anywhere. So there can be multiple partitions, right? There can be a partition like this, there can be a partition like this, a partition can be like this, and so on. Like something like this as well. So out of all these partitions, whichever will yield you the best answer, you have to tell us that. So generally, all the problems which are like in a pattern, that can be solved using partition DP. And you have to basically, I can say, whenever you try to partition it in this way, you have to solve this portion, which you can call from I to K. So this portion, if you solve it like this is nothing but f of I to K. When you solve this is nothing but K plus 1 to J, right? So again, if you're trying a K here, this is I to K, and this is K plus 1 to J. So similar pattern of problems can be solved using partition DP. So I just gave you an idea about how to approach the problem. So in order to understand partition DP, the first problem that we will solve will be MCM. What is MCM? Matrix chain multiplication. Okay, so in order to understand this, let's first understand what is matrix multiplication. Okay, so assume I give you 3 different matrices A, B, C, and the first dimension is 10 cross 30, the second dimension is 30 cross 5, the third dimension is 5 cross 60. So if I ask you, there is a matrix of size 10 cross 30, and that's the A matrix. There is another matrix of B, which is 30 cross 5. Can they be multiplied together is the question. Can they be multiplied together is the question, and the answer to that is yes, right. They can definitely be multiplied. Why? Because if you have done maths in your school, you know, if these guys are equal, if the column of the first matrix is equal to the row of the second matrix, then the multiplication is possible. And how many operations do you require? Is how many operations do you require in order to multiply this? That's very simple. You take this guy 10, you take the common guy 30, and you take the other guy 5. So the number of operations or the number of multiplications required in order to multiply both the matrices will be 10 cross 30 into 5, which is somewhere around.
Yes. So we should be thinking about that.
$1,500 operations if I've done the calculations correctly. Yeah, I've done it correctly. Now, what are these operations now? If you know, if I'm multiplying some matrix like this, how many operations we generally do? This is nothing but a 2 cross 2, and this is nothing but 2 cross 1. So again, this is equal. So multiplication is possible.
Numbers make my head spin. How can I make this easy? Bruh, for students, Google Gemini Pro is free.
What will be the resultant? The resultant will be a matrix of this size 2, of this size 1. Correct? How many operations will you do? 2 cross, common 2 cross 1, which is 4 operations. Why 4 operations? Because first you multiply 1 into 2 plus 2 into 3. So what do you do? 1 into 2 plus 2 into 3. Next you multiply 3 into 2 plus 1 into 3. So 3 into 2 plus 1 into 3. So how many operations did you do? 1, 2, 3, 4. So there are 4 multiplications that you did. So that's easy to find. You write the first guy, you write the common guy, and you write the other guy. So if you multiply them, you easily get the number of multiplications or operations in order to multiply them. So these are the basics that you need to know. So assume I give you these 3 matrices. Let's again try to write it. If I give you A, B, C, okay, and I ask you to multiply them. What is A? A is 10 cross 30. B is 30 cross 5. C is 5 cross 60. Now, if I ask you to multiply them, what are the ways that you can multiply? Obviously, there are a couple of ways. One is you say, Striver, I will be doing it A, B, C. Like first I'll multiply AB, then I'll multiply C. Okay, that makes sense. So if I do the multiplications this way, let's see what will be the number of operations. So if I'm multiplying AB, that's 10 cross 30, and B is 30 cross 5. So what will be the number of operations? What will be the number of operations? 10 cross 30 cross 5 will be the number of operations. Agreed? So what will AB give? What will AB give? AB will give a matrix of 10 cross 5 again, because this is 10 and this is 5. So AB is going to give you a 10 cross 5 matrix. What is C? Let's write about C. C is nothing but 5 cross 60. So once you multiply AB, it will be a 10 cross 5 matrix. Now C will be a 5 cross 60. What is the number of operations? 10 cross 5 cross 60. So if I try to sum it up, this will be 1500 plus 3000, which gives you 45,000 or something like this. I think 4500 rather. 4500. 4500. So I get 4500 operations, which is indeed massive. Yeah, that's indeed massive. So let's write down the operations. It's 4500 operations. That's one of the ways. What will be the other way? I get this right. Listen. First, why don't you multiply BC? And then let's multiply the resultant with A. I'm like, okay, makes sense. What is B? B is 30 cross 5. What is C? C is 5 cross 60. Okay. So if I multiply these couple of guys, I will get the number of operations to be 30 cross 5 cross 60. Makes sense? And the resultant that I will get will be 30 cross 60, because this is common. So the resultant will be 30 cross 60. What is A? A is 10 cross 30. A is 10 cross 30. So can I say this? The number of operations required will be 10 cross 30 cross 60, which this will give you, the number of operations will be 9,000 for this and 18,000 for this, which will give you 27,000 operations. So which way of multiplying these 3 matrices? So which way of multiplying these 3 matrices was a better way? I can say, if I multiply this way, I will take 27,000 multiplication operations. But if I multiply first AB and the resultant with C, then I'll just take 4,500 operations. Is there any other way? Obviously not. So what I figured out was the minimal operations required. Yes, the minimal operations required was 4,500. So I wanted to print this. Basically, given the dimensions, given the matrix dimensions, given the n matrix dimensions, tell me the minimum cost to multiply them to a single one. So for an example, if I take 4 matrices, A, B, C, D, what can be the different ways? I can be like, I can do something like this. I will like first multiply CD, the resultant with B, and then the resultant with A. That can be one of the ways. I can be like, first multiply EB, then multiply CD. So first get the resultant, and then multiply both of them. Or I can be like, why don't you do this? A, B, C, okay, makes sense. Then D. So it's something like first multiply BC, then the resultant with A, and then the entire resultant with D. So there's a lot of ways. There's a lot of ways in which you can multiply. So again, which kind of DP? I told you, partition DP. Whenever is, I can be like, I can do something like this. I will like first multiply CD, the resultant with B, and then the resultant with A. That can be one of the ways. I can be like, first multiply EB, then multiply CD. So first get the resultant, and then multiply both of them. Or I can be like, why don't you do this? ABC, okay, makes sense. Then D. So it's something like first multiply BC, then the resultant with A, and then the entire resultant with D. So there's a lot of ways. There's a lot of ways in which you can multiply. So again, which kind of DP? I told you, partition DP, whenever a problem can be solved in different patterns, because I saw, if I was asked to multiply ABC, there's two ways in which I can, this or this. And when I was asked for ABCD, there can be multiple different ways. So whenever such a problem arises, you think of partition DP. Yes, you think of partition DP. So what is given to you? Let's understand what is given to you. You are given an array. Remember this. You are given an array. Okay. Now, the example that I took was of 4 matrices. Okay. So imagine if I give you an array of 10, 20, 30, 40, 50. Over here, n is 5. Over here, n is 5. So if n is 5, this array resembles the dimensions of n minus 1 matrix or matrices. Let me explain. So if I ask you, what is the dimension of A? The dimension of A will be 10 cross 20. If I ask you, what's the dimension of B? It will be 20 cross 30. If I ask you the dimension of C, it will be 30 cross 40. If I ask you the dimension of D, it will be 40 cross 50. So basically, 10 cross 20, 20 cross 30, 30 cross 40, 50. So if I try to index them, so can I say, for the first matrix, the dimension is A of 0 into A of 1. For the second matrix, the dimension is A of 1 into A of 2. For the third matrix, the dimension is A of 2 into A of 3. Thereby can I write, for any given input, the ith matrix will have a dimension AI minus 1 into AI. Makes sense. Yeah, favorite. Makes sense. So I can say, I have figured out this, that the dimensions are given in this way. For any ith matrix, the dimension is A of I minus 1 into A of I. Okay, so you will be given this dimensions. You know the number of matrices are 4. Tell me the minimum number of operations required in order to multiply these matrices. This is the simplest question. So I hope you have understood the question, right? So how do you solve this problem? Definitely. The way is partition DP. Again, whenever there is a pattern of DP, you have certain rules. Yes, you have certain rules. Rule number 1, start with entire block. Remember this, start with entire block or array. What does this mean? Over here, we have 4 guys. So you say the function, hey, take the 4 guys and give me the answer. Yeah, you say the function, take the 4 guys and give me the answer. Like, it will be something like this. Let me just explain. So if I'm writing A, B, C, D, so these are the 4 guys. You start with all the 4 guys and you're like, okay, hey, listen, how can I solve this? I can either go like A, B or C, D. I can either go like A and probably B, C, D. Or probably I can go like A, B, C or D. Correct? So what you're trying to say is, okay, I was solving this. Now what I'll do is I'll try to break the problem down into smaller problems. How can the small problems be? It can be A, B, C, D, or it can be A, B, C, D, or it can be A, B, C, D. So what I did was I took the entire problem, broke it down into something smaller, and I tried to solve it. And whichever way gives me the minimal will be my answer. So you will always start with the entire portion. You'll always start with the entire portion. Remember this. And you can always mark them by IJ, where I is the start point. Like over here, I will be this A and J will be the D. Over here, I will be this, J will be this, I will be this, J will be this. Over here, I is this, J is 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 this. Because this in itself is a problem that you're wanting to solve. This in itself is a problem that you're wanting to solve. So I is the start point. J is the ending point. Remember this. Start point and the end point is given to you. Perfect. So start with the block and array. Always represent them by IJ. Always represent them by IJ, where I is the start point and J is the end point. Rule number 1. Rule number 2. Try all partitions. Try all partitions. Very important. Try all partitions. And how do you figure out which partitions are possible? Let's see. Over here, a partition was here. Over here, partition was here. Over here, partition was here. Over here, you cannot again solve the entire thing. So there are 3 partitions. One is here, the other one is the middle, and the other one is here. There are 3 partitions. So probably you can run a loop to try out all partitions. Probably yes. Like so, run a loop. I'll explain you the loop. Run a loop to try all partitions. Remember this. Run a loop to try all partitions. Okay, makes sense. Next 3. Return the best possible 2 partitions. Best possible 2 partitions. What do you mean by 2 partitions? Let's understand this. 2 partition. 2 partition. 2 partition. One is the middle and the other one is here. There are 3 partitions. So probably you can run a loop to try out all partitions. Probably yes. Like so, run a loop. I'll explain you the loop. Run a loop to try all partitions. Remember this. Run a loop to try all partitions. Okay, makes sense. Next 3. Return the best possible 2 partitions. Best possible 2 partitions. What do you mean by 2 partitions? Let's understand this. 2 partition. 2 partition. 2 partition. Which 2 partition is the best? Which 2 partition is the best? You return it. So 3 steps. Start with the entire block. Try all partitions because you're going to try out every possible way to solve it and return the best possible 2 partition. That's it. So you take the entire problem, break it down into smaller problems, every possible small problem, and you try to solve it. And you return the best possible partition that was like best possible sub problem that you could break into. That's the straight funda. Okay. So something we've understood that we have to start with f of ij, right? That's for sure. Now what was given to us, like we knew that we had A, B, C, D, but we cannot think in terms of A, B, C, D. We have to think in terms of the array. Let's understand, we have to think in terms of the array. And if you remember, the array was something like 10, 20, 30, 40, 50, correct? And can I see this? A was nothing but 10 into 20. The second matrix was 20 into 30. The third matrix was 30 into 40. This matrix was 40 into 50. Can I say this? I can. Thereby, what I can say is, hey, listen, if I'm starting with, I can say this A, I can say this B, I can say this C. Where? If I'm looking for A's size, it's this guy and the previous guy. I'm looking for the B size, it's this guy and the previous guy. I'm looking for the C size, it's this guy and the previous guy. Something to the formula that we decoded. Previous into current. Thereby you can say if I'm resembling, A, B, C, D, because that is what I'm looking to solve. My I will start here, that's the starting point, because that's what A is. My J will be the ending point. My J will be the ending point rather. Thereby I can say the starting point is 1 and the ending point is n minus 1. Over here, can I say, please solve me 1, 0, 1, 2, 3, 4, 1, 4. Please solve me the matrix 1 to 4. In what way? Returns the minimum multiplications to multiply matrix 1 to matrix 4. Remember this. It is the minimum multiplications to multiply matrix 1 to matrix 4. So we have got a start point which is 1 and which is n minus 1. So every time the problem will start over here with f of 1, n minus 1. In other problems you have to determine in this way. Like over here, since A was meaning this guy, this guy into this guy, thereby I started here. In some other problems I might start here, J might end here. You have to figure where does your entire block lies. Once you figure it out, it becomes very, very easy. So you have understood what f of ij means. It states this is the block and give me the minimum operations required. Okay. First step done. Determine in this way. Like over here, since A was meaning this guy, this guy into this guy, thereby I started here. In some other problems I might start here, J might end here. You have to figure where does your entire block lies. Once you figure it out, it becomes very, very easy. So you have understood what f of ij means. It states this is the block and give me the minimum operations required. Okay. First step done. What is the next step? To write the base case. So what am I solving? I'm having an entire set of matrix for which I'm asking minimum operations. What will happen to this ij? Let's look. Ij actually shrinks. Whenever you will do partition, they will shrink. They'll shrink. So initially this is this much. Then a shrink will happen. Then a shrink will happen. Then a shrink will happen. What is the minimum that you will go? Ask yourself. If you like Trevor, and the minimum that we will go is nothing but when it's a single array. So the base case is very simple. If I is equal to j, you're solving an entire block. You shrink it, and you have came down to a portion where it is just a single matrix. Then the number of operations. What are the number of operations? Ask yourself. It's 0. The number of operations required is 0. So we figure out the smallest base case. The smallest case is when we just have a single piece of matrix, and thereby I can say we can easily return 0 because the number of operations will be 0. Start with the entire block. Done. Base case has also been written. Wow. So let's talk about the second point. Try all partitions. So let's go back and take the same example. This is the example given where we have this as the starting point, this as the ending point. So we just write A, B, C, D. That will make things easier. Can I say I can have something like this? I can do a multiplication like this where I again solve this portion. Or I can have something like this where I solve this and I solve this and then I just add them up. Or I can have something like this where I solve this and I solve this and I add them up. So like, yes, that actually makes sense. So can I say, if I probably, if I run a loop A.
Introducing Grammarly like you've never seen before. Your all-in-one writing essential. This?
If I run a loop A, because first partition is this, the second partition that I can do is this, the third way that I can try is this. So can I say, if I run a loop from I to j minus 1, if I run a loop from I to j minus 1, for the first time, can I say it will be something like the first partition will be I to k, and the other partition will be k plus 1 to j. We need to understand why j minus 1, I'll explain you that. Let's understand this. Let's take this example and try to write the values. 0, 1, 2, 3. So where is k? K is trying to go from 0. Let's try to write down the indexes so that this gets better. So k is basically running from 1 to 3. So what am I saying? 1 to 1 and 2 to, what's j? J is 4. So basically the first time, whenever k is for the first time, whenever k is 1, what happens? I'm saying 1 is to 1, which means just this guy. 2 is to 4, which means this guy. Next step, when k is 2, I'm saying 1 is to 2 and 3 is to 4, which means 1 is to 2 and 3 is to 4. Or I can say, if k is 3, I'm saying 1 is to 3 and 4 is to 4. Does that make sense? I'm basically trying to have different partitions. I'm trying to have different partitions. Make sense? This can be one of the ways in which you can go from I to j minus 1. I hope you understood why did I go till j minus 1. Because if you go till here, then there will be no one on the right. Therefore it's very important you go till j minus 1 because the right guy is k plus 1. So if you go till j, then k plus 1 will not be valid. So it's very important, please make sure you go till j minus 1. Or one of the other ways is, you can do the other way as well. You can say, Striver, I will do k equal to I plus 1 and j till j. I'm like, okay, if you do this, then the partition will be I to k minus 1 and k to j. That's it. If you're running the loop from here to here, which means 2 to 4, then let's see what happens. If I is 2, which is the initial case, then it will be like 1 comma k minus 1. So 1 comma 1, f of 2 comma 4. I is, rather k. If k is 3, it will be 1 comma 2, 3 comma 4. If k is 4, it is going to be 1 comma 3, f of 4 comma 4. It's the same way. Either you run till j minus 1, then you will do a partition from I to k and k plus 1 to j. Or if you run from I plus 1 to j, you're going to do a partition from I is to k minus 1 and k is to j. Both of the ways are correct. So what did I say? Do the partitions. In order to do the partitions, I know very simple. What do I need to run? I need to run a loop. And you can run any loop. So I will prefer running it from I till j minus 1. So that's what I will prefer. So I'll run a loop from I to j minus 1. That is something which I will do. Okay, what's the next step? We have to figure out the number of steps. And after that, we have to probably return the minimal of all steps. So let's understand this because second point is kind of half done. Return the best possible to partition. Let's understand this. This will give me some answer. This will give me some answer. And what do I need to take? I need to take the best among them. So let's understand. How much answer? Like if I do it f of 1, 1, f of 2, 4. How much answer does this basically gives me? So A was 10 cross 20, B was 20 cross 30, C was 30 cross 40, D was 40 cross 50, correct? So we had 4 matrices, and this was f of 1 comma 1. So 1 comma 1 means one block of A, which will be 10 cross 20. And can I say if you're multiplying BCD, at the end of the day, what will be the resultant? What will be the resultant matrix? So if you can try multiplying, it will be like B is this, C is this, D is 40 cross 50. So this is nothing but A. But if you multiply something as BCD, what's the resultant matrix? So assume you multiply this, you get 20 cross 40. Assume you multiply this, you get 20 cross 50. That's what you get. Even if you do it the other way, which is 20 cross 30, C is 30 cross 40, D is 40 cross 50. Even if you do it the other way, it's 30 cross 50, 20 cross 30, and if you can do it, it's 20 cross 50. No matter in which way you do the multiplication, the resultant matrix will be of size 20 cross 30 only. So I can say 20 cross, rather 50, my bad, 50. So that's the resultant size of BCD. So if A is this, BCD is this, what are the number of operations that you'll be requiring in order to multiply A and BCD? Because A was a part, BCD was a part. In order to multiply them, can I say the number of operations will be 10 cross 20 cross 50? That will be the number of steps, right? So where is 10 actually? Can I say, if you remember well, 10, 20, 30, 40, 50, I was here, J was here, and K would be probably here for this case, right? Where is 10? Let's see, where is 10? Can I say whenever you try to multiply A and BCD, where is 10? 10 is right before I. So the number of steps required will be A of I minus 1 multiplied with, let's see. Let's come back. Where's 20? Can I say 20 would be here? You'll be like, it's I. It's actually not I, it's K. Try taking some other partition, I'll show you that. It's actually K. So what you can do is, you can easily write array of K now. How's the other one? The last one is 50. Where's 50? At J. So the last one is array of J.
Wait, so you were a salesperson last month and now you're a Python developer at TCS?
Yes.
But how? I mean, don't you require some prior...
So basically that signifies this, you have 2 parts. So when you combine them, the number of steps required will be this, right? Now you have 2 partitions. What are the 2 partitions? F of I k and f of k plus 1j, because BCD in itself will take some number of steps. BCD in itself will take some number of steps to get multiplied. So I can say, okay, the I comma k will take some steps. Let the function give me that, because I want the minimal number. Function will give me that. Or k plus 1 comma j will also. The left guy will take some steps, give me the minimal. The right guy will give some steps, give me the minimal. And these will be the steps. If I do a partition on k, right? And what I can say is, okay, I'm the minimal of all. Probably I can store a mini equal to bigger value, and I can say mini equal to minimal of mini comma steps, because I need the minimal among all. So this will make sure it gives me the minimal among all, and in this way I have pretty much solved the problem. I k and f of k plus 1j, because BCD in itself will take some number of steps. BCD in itself will take some number of steps to get multiplied. So I can say, okay, the I comma k will take some steps. Let the function give me that, because I want the minimal number. Function will give me that. Or k plus 1 comma j will also. The left guy will take some steps, give me the minimal. The right guy will give some steps, give me the minimal. And these will be the steps. If I do a partition on k, right? And what I can say is, okay, I'm the minimal of all. Probably I can store a mini equal to bigger value, and I can say mini equal to minimal of mini comma steps, because I need the minimal among all. So this will make sure it gives me the minimal among all, and in this way I have pretty much solved the problem. Yes, we have. So every partition DB. Remember, this is important. You will always have to do a partition, always. And after that, this is MCM, so you compute the number of steps. There might be some other problem. Steps computations will be on the problem, but the left portion and the right portion will be solved by calling the recursion. Steps computation will depend on the problem. Like in MCM, you figure out this is what we are having. In some other problem, it might be something else that you have to figure out. So in order to understand the formula again, let's write the same thing: 10, 20, 30, 40, 50. Imagine I was here, and I'm saying A is here, and I'm saying J is here. Imagine this is a starting point where I'm like, okay, divide them into AB and divide them into CD. Something we know for sure is this is 10 cross 20, this is 20 cross 30, this is 30 cross 40, this is 40 cross 50. And we something like, we definitely know this is going to give me 10 cross 30, this is definitely going to give me 30 cross 50, and when I multiply them, I'll get 10 cross 50 as the resultant. As the resultant, this is what I'll get, right? So can I say the number of steps? Because at the end of the day, AB was 10 cross 30, and CD was 30 cross 50. So the number of steps, if you take CD and if you take AB, will be 10, 30, and 50. So again, you can relate. What's 10? I minus 1. What's 30? K. What's 50? A of J. So this is how the number of steps can be easily found. It's just before I, K, and J. That's what the number of steps will be, no matter how you multiply. And what you can do is you can solve this guy by calling the function, and you add this guy. So this will be the total number of steps taken, in short. Cool, I hope that makes absolute sense. So now what I'll do is, I'll try to show you the recursion tree so that the working also gets clear, because it's very, very important. If you don't understand the working, it's going to be very messy. Let's understand the working as well. So what is the recursion tree? We started with A, B, C, D, or we were something like, okay, let's take 10, 20, 30, 40, 50, okay? And we were something like, this is A, this is B, this is C, this is D, and this is our I, and this is our J. That's how the recursion started. This was the initial function call. Now, what kind of partitions you did? You did 3 kind of partitions over here. One partition you called was, you said, hey, listen, I know one thing for sure. I will myself take, if I do a partition something like this, if I just do a partition for 20, and I is E, J is E, and this is the A. And the other one is 30, 40, 50, where I say, this is B, this is CD, and I is this guy, and this is J. Basically what I did was, I said, just take A, and just take B, C, D. So just take A, and just take B, C, D. There can be 2 kind of partitions that I can do, right? So that's the first partition that you can do for K, where K will be initially over here. And this is what the partition will take place. Next time if you move K here, then it will be AB and CD. So you can again probably write, okay, it'll be AB, which is something like 2030, and CD, which is nothing but 4050. If it makes sense. And this is this time, this is I, and this is J, and this time, this is R, this is J. Or the other one can be K is here, there are ABC and D, if K is here. So what you can do is there can be another portion of time, which will be ABC, which is 20, 30, 40, and there's another thing D, which is 50. And this time, I is here, J is here, this time I is here, J is here. Perfect. Let's analyze. So we have, take whatever we have. This, whenever you run the K is here, it takes this guy, then K is here, takes this guy, then K is here, takes these guy. Or all of these three partitions, whichever gives you the minimal, you're gonna take that. Okay, so what's the first step that will run in the recursion? When K is here, this will get solved, and it'll have some number of steps. So let's just solve this. You'll get a pretty decent idea, then you can solve this by yourself. So what will this guy return? It's a single matrix. Number of multiplications will be 0. Perfect. So I know one thing. A and B, C, D, they themselves will take 10 cross 20 cross 50, 10 cross 20 cross 50, because A and B, C, D themselves will get multiplied to take 10 cross 20 cross 50. And there was an F of this guy which gave you 0. And there's this another F guy which you have to figure out. Okay, so you have to solve this BCD now. You have to solve this BCD. So if I just take this BCD away again, and I write 30, 40, 50, and this is where the I and J is at. Now how will the K work? K will be like, okay, once I can be here, and the other one I can be here. So there can be two possible ways. When I say I am B, and I can say I am CD. There can be other possible way where I'll say I am BC, and I am D. Perfect, makes sense. Now can I say this? This time again, this guy will return 0, and then CD.
शानदार ऑनलाइन एक्शन गेम वॉर थंडर आपके उबाऊ सप्ताह के दिनों को खत्म करने के लिए तैयार है। प्रसिद्ध जापानी बैटलशिप मैदान में आ रहा है। क्या किसी ने भारी आर्टिलरी
If you solve CD, basically, whenever you add this guy, this is returning 0. If you solve CD, again it will go and solve C and D in two possible ways. I'll give you some possible answer. And you will eventually get the value, like which is the minimal of BCD, and that will come over here. And this will be added for this partition. Similarly, you'll get for this partition. Similarly for this partition. And you can easily get the minimal of this, this, or this, and that is going to be your answer. Now, I could have done the recursion tree, but it will become very, very clumsy. Probably you can take pen and paper and write the recursion, but if you're good at recursion, you can visualize, right? So that's how you will do it. Let's quickly recap the entire thing because I know it has been a lot of information. Let's quickly recap it. This video is going to be long. So we started with partition DP, where I said you just have to decide in which ways you have to do, and you have to figure out the minimal. That's where you apply partition DP, and it's a tough part. So the problem that we solved was matrix chain multiplication, where we are given a matrix, n number of matrices, and we are being asked in what way will you multiply them? Like in which order will you multiply them? Like you can multiply AB at first or C, or you can multiply A and BC. So you have to multiply and figure out the minimum number of operations, which of the pattern give. So I said, okay, I'm going to use partition DP. Why? Because there are different patterns in which we can do. And whenever that is that's when we can apply partition DP. So we said that, okay, given in dimensions, tell me the minimum cost. So we were like, okay, fine. So we were given an array where we said that this is A, this is B, this is CD. And the size went on as A, I minus 1 into AI. Because if this is A, the size is 10, 20. If this is C, the size is 30, 40. Thereby, this is what the ith matrix size went on as. Now, I said I'll apply partition DP. So I said the rule is very simple. You solve the entire block. You solve the IJ block. I'm like, okay. So over here, A was this, B, D was this. So this is the entire block. So you started from 1 and you went on till 4 rather. You went on till 4. So you just solved it like this. So I was like, okay, fine. We've understood that f of 1 to n minus 1 is what represents the entire block from A to D. So this means minimum multiplications to multiply matrix 1 to matrix 4. If this would have been f of 3, 4, minimum to multiply matrix 3 to matrix 4. As simple as that. Got it? So that's what I wrote as the first case. Start with the block. Next, base case. What about the base case? Base case is very simple. You know what is the smallest because you're taking the entire block to start off with. And when you're solving, if you're taking the entire block, it's a larger portion that you're starting from. So top, down, which is the lowest portion. It's going to be a single array element. So whenever it's a single matrix, there's no multiplication required. Thereby 0 steps return. What's the next step? I said, I'm going to try out all partitions. And how can I try out all partitions? It was very simple. I said, okay, listen. One of the ways is I can go like this, like this. The other way is I can go like this, like this. The other way is I can go like this and like this. Okay. So I have to call for this guy and for this guy. So I can keep a k here and I can call ik and k plus 1 to j. That's what I thought. Or probably I can keep a k here and I can call for kj and I can call for a of I k minus 1. Either I can call for these couple of guys or I can call for these couple of guys. Depending on how am I looking to place k, because my main motive is to call these couple of guys. Doesn't matter if you call by this or by this. On that basis, we run a loop from I to j minus 1 or from I plus 1 to j. Simple. So we run a loop from I to j minus 1. And after that, we figured out that if there are two quotients, we multiply. Then when they came across, the steps required will be this, and we got this formula. But this has to be solved. This is solved by calling f of ik. And the other portion has to be solved, so this is solved by solving this. And this is the steps for one type of partition. There can be k type of partitions. Take all the steps and take the minimal of all the steps. And that's what you return. And in this way, you can easily, yes, I repeat, in this way, you can easily get this problem to be done. So without wasting any time, let's quickly code this up. So you're given the array and you're given the n. So you remember, we need to write a function which basically is from 1 to n minus 1 and array, right? So let's quickly write a function from this. And we will have an f, we will have an int j, and we will have a vector of int and array, right? And I can say if it's a single size, we can definitely return 0. And what's the next step? You just do the partitions. So the partitions will be from I to k lesser than j and k plus plus. Basically, till j minus 1 is what the partitions will be. In the minimal, so probably keep the minimal mini equal to I9 or something like this. And you know the steps, you can easily compute the steps to be very simple. It's array of I minus 1 into array of k into array of j plus 8. Once you've got this, solve the first portion, which is I to k, comma array. And so the other portion, which is f from k plus 1 till j till array. And whatever you get, if that is lesser than the previous partition steps, you basically replace mini equal to steps. At the end of the day, you can easily return whatever mini you've computed. Right? And what you can do is, let's quickly
everybody, there are 5 stars series stage of crush gathering. And I don't get it. Running came from the mud. I didn't get a head of fire. Banda di palade dove dove pau, dove se si canta, ora mo hota bonta babe sado satisfy. Noi zindagi batate ave se ram. Dove vita na viva, na viva na viva. Ada parang, ada parang. Don't cherry. Congrats, buddy. अभी तो टाइम है यार, काफी टाइम है। प्रसाद भाई, काफी ज्यादा टाइम। Lower the gun and say, "Bah, I like the button and the da." Just out there to make it fun. Yeah, I'm thinking that people tell me. ज्यादा वो तड़पते चुकी तो चेहरे ही नहीं वे बंदे पाते था विदासी खुशहालों के लिए भावे लॉन्ग सेक्शंस मुझे आते हैं फन आई फन ज्यादा वो तड़पते चुकी तो चेहरे ही नहीं आगे उड़ा दो यार फन Any bonnet, donne, any gonde, bonde, any bonne, देखा तेरे
I have a story about a talking samosa. Can Gemini make it into a movie?
Of course. Upgrade Google
In this video, we will discuss the problem brackets in matrix chain multiplication. Previously, this problem has been asked in some of the product-based companies. So the problem says that we'll be given an array T, which will be of length n, and it will be used to denote the dimensions of a series of matrices such that the ith matrix is denoted by pi into pi plus 1. So the dimension of the ith matrix is pi into pi plus 1. Okay. Now there are total n minus 1 matrices given, and we have to find the most effective way to multiply these matrices together. I'll explain this. Basically, first of all, what we have to do is we have to consider the matrix chain multiplication problem, and then after we have solved the matrix chain multiplication, so we will apply the brackets in this problem accordingly. So the problem is not actually to perform the multiplications, but merely to decide in which order to perform the multiplications. So basically, we have to decide that in which order we'll be multiplying the matrices, such that the minimum number of operations is needed. So there are many options to multiply a chain of matrices because matrix chain multiplication is associative in nature. We'll see this in the notes part as well. So no matter how one parenthesis is the product, the result will be the same. So let us see some of the cases here. So let us say that if we take a matrix, like first of all, let us understand what they are saying. So they are saying that given the matrices, multiply in such a way, you have to multiply the given matrices in such a way such that the total number of operations, right? Basically, the total number of operations that we do should decrease, right? Should be minimum possible. Now, what do we mean by that? Is there any difference when we multiply matrices in terms of operations? Yes. Suppose there is a matrix A which is of dimension 1 cross 2. Suppose that matrix A is of dimension 1 cross 2. Suppose there is a matrix B which is of dimension, let's say, 2 cross 3. Suppose there is another matrix C which is, let's say, of the dimension 3 cross 4. So if I apply the associative property of matrices, so we can understand that A into BC, where BC is multiplied before, okay, where BC is first of all multiplied, then the result is multiplied with A, is equal to AB into C, okay, because the matrix multiplication is associative. So let us see that how many operations we will take in the case of A into BC, okay. So in the case of A into BC, how many operations we will take? So first of all, we will multiply these two matrices. So if we multiply B and C, so how many operations we actually take? So we take nothing but 2 into 3 into 4 operations, okay. That is nothing but this. 3 is common, then 4. So 2 into 3 into 4 operations is what we take. Then we get the resultant matrix. So we will get the resultant matrix BC, which will be of the dimension 2 cross 4. And we also had a matrix A, which was of dimension 1 cross 2. So when we multiply this thing, that is A into BC combined multiplied. So we will get what? We will get another thing that is 1 into 2 into 4. So the overall cost will be 1 into 2 into 4 plus 2 into 3 into 4. Okay. So this is quite high compared to the other cost. Let us see what we will get when we multiply in other fashion. So let's say we have the matrix like A was there, that was 1 cross 2. Then the matrix B was there, which was 2 cross 3, let's say. Then let's say the matrix C was there, which was of the dimension 3 cross 4. So if we have these three matrices, suppose we tried another way, and the other way was AB first multiplied, then we multiply the result with C. If we multiply these two matrices, so in that case the result, the cost for it would be 1 into 2 into 3, and then once we have multiplied this AB matrix, so this AB matrix will be of dimension 1 cross 3. Now what will happen? I'll multiply this with the matrix C, which is of dimension 3 cross 4. So this will take up a cost of what? 1 into 3 into 4. So if we try to see the overall cost, so this is 6 operations plus 12 operations, so total 18 operations is what I'm taking here. In this A, B into C, I'm taking 18 operations. But if I look up here, so I was taking total of what? How many operations? This was 8 plus 12 into 2, that was 24, so total 32 operations I was taking. So you can see that I'm getting some lesser operations there. So my task will be to minimize the number of operations that I'm doing. And how we can do it? So basically we will try, like if suppose that we have been given a bigger matrix combination, let's say we have been given matrix A, B, C and D, so we can try to do what? We can first of all try and find, let's say we can try to do the partition. Let's say we do the partition one time here, then one time we do the partition from here, one time we do the partition from here. So we'll try to do the partition from various possible scenarios. So what will happen is, we'll have A, okay? First of all, let's say we have A, then we have B, C, D combined, okay? So we are doing the partition at A. Then another thing that we could have done is, we could have done the partition at this position. In that case, it could be A, B, and then C, D, okay? Suppose if we do the partition like this, okay? So we will get some cost from the left side from this AB multiplication, some cost from CD as well, and then suppose they are having the dimensions as A cross B and B cross C. So in that case, what would happen is, basically my overall cost will be nothing but the left cost that I'm getting, the left cost that I got, okay? That is the cost for AB, for getting this product as AB, plus the right cost, plus A into B into C, okay? So that is how we will get the cost each and every time. So how can we do this particular initiative? So now let us discuss this one as well. So let's say we are having this part. So this will be nothing but A, B, C combined, and then D. So how will we get this? So again we will first of all we'll have some operations for the left that will get through the recursive call, some operations through the right part that will get from the recursive call. Here will basically the number of operations will be 0 for this. Now so like this will be added with what? The dimensions, like suppose it is A cross B and this is B cross C. So the cost will be A into B into C, right? So this is how we'll take the overall cost. Now let us understand how we'll get some overlapping problems here. How does this fall into dynamic programming or overlapping subproblems? So let us see this. So if we are talking about this, so this would be taken like this: A, then D could go alone, and then C and D, then D could go alone here, and then C and D could be there. Or what could have happened is, it could be A, then B, C, and then D, and similarly for other cases. But if we will try and observe, so this particular subproblem C and D, if we observe this problem C and D which is there, it is also here. So we can see that how the problems are repeating. So we will not calculate the repeating subproblems, and for this, if we are following a top-down approach, then we will use memoization for not calculating the already stored answer again and again. So what we will do in the normal part is, we will try to do the partition at every step. So let us have a look at the normal matrix chain multiplication code. So basically what we have is, in that case we have a 2D vector named as DP, which is of the dimension n cross n for storing the I, j situation. So initially we'll mark it as -1, indicating that the particular state dp of ij is not calculated. Then what we do is we run a recursive call named as function f. This function f will be recursive. We'll start from 1 till n-1. So that is where we can do the partition. We'll pass the array, we'll pass the n, we'll pass the dp part, and then in this function, if I is equal to j, so if I is equal to j, so that means that I and j are pointing at the same values. So this basically indicates that there is no matrix multiplication possible. So in that case we simply return a 0. Otherwise we check if the dp and ij. This is the code for matrix chain multiplication. We'll also see the code which is very similar for the brackets in matrix chain multiplication, because if we know matrix chain multiplication properly, then we'll be able to implement the string addition part in the matrix chain multiplication itself. So we will then what we'll do is we'll say that we'll have the minimum initialized as int maximum. Then we will try to partition it at every step. So I'm starting from I and ending at j. So I suppose I've been given a matrix A, B, C, D. So I'll try to partition it at every step. So I'll start at k is equal to y and k is less than equal to j minus I, k plus plus. Then the number of steps at that particular point would be nothing but the left part that gives me starting like from I till k, from I to k, passing the array and the dp as the same. Then from k plus 1 to j. So this is the left part that I get. This is the right part. So left part plus right part plus the current multiplication. That is nothing but array of I minus 1 into array of j into k. As we were discussing for these cases. Like for this case, there will be a left part that we have already calculated. Then there would be a right part.
ChatGPT can now create website wireframes. With our new custom GPT, we guide you through the process
plus the dimension. So suppose A cross B is the dimension and C cross B cross C is the dimension. So plus left plus right plus A into B into C. Okay, that will be our overall cost. So we'll see that. Then if it is minimum, then we'll store it. And then after we have done the computations for this particular, so suppose we have done the computations for this particular state, then what we'll do is we'll try to store the minimum, and for this dp of ij, we'll store the minimum. Okay, so that is how we'll be minimizing our number of operations at every step. Now talking about the brackets in matrix chain multiplication. So basically, suppose if the dimensions are given to you, suppose the dimensions are given as 1, then let's say like it is given 10, 20, and 30, and let's say 40. So basically, how many matrices would be there? There would be 3 matrices. So if A, B, C is there, so we need to determine that whether A, then B, C is doing giving us minimum operations, or AB and then C is giving us the minimum operations. So we can find this using the DP approach here only, but in this case we have to use the brackets, right? The concept is that we have to represent the matrices in terms of A, B and C, and we have to use the brackets as well. And for doing this particular approach, what we can try to do is we can try to have a DP which will not only be storing the value, right? In this case, the DP will not only be storing the operations or the minimum value for the particular I and j, it will not only store the minimum value, but also it will store the string. Okay, that is what will happen here. So let us discuss. I've taken this code from the description. It was written really well. So basically what we'll be doing is we'll be declaring a vector of vector, but basically a 2D vector that will be consisting of a pair. The first part of the pair we have taken as a string, and the second part is integer. So the string part will be storing the brackets, will be storing the sequence in which will be storing the brackets according to the minimum operations, and integer will tell us the minimum number of operations. So initially we'll mark the string values as null, and we will mark the integer values as -1, indicating that the current DP state ij must, if it is equal to -1, so that means that that particular state is not calculated. Then we'll call our function recursively, okay, passing this particular thing, passing this particular DP there, and we'll start from 1 to n -1. What we used to do in matrix chain multiplication, the concept is exactly the same. And then after this computation has been done, so we have to return what? We have to return the string. We have to return the brackets in the matrix chain multiplication, and that will be stored in the first part of this pair. So basically, when this recursive function returns us, so if we have to have a pair, so this will return us a pair. So in the first part of the pair, the string will be stored. The brackets in the matrix chain multiplication will be stored in the optimal way. So that is what we have to return. We don't have to return the value in this case. So what the code is exactly the same. This function will return us a pair of string comma int, and we'll first of all pass the p array that is given to us. We'll pass the I and the j, and we'll pass the dp array. Okay. And what we will do is if I is equal to j. So if I is equal to j, what does that mean? So if I is equal to j, so that means we have reached the base case. So if we reach the base case, in that case we know that we used to return 0. If you remember, we used to return basically 0. 0 meant that the cost was 0, and that was it. But here we have to use if we have to implement. So what we will do is we will have to generate all the characters a, b, c, d as well. So we can use this base case for generating. So based on the value of I, if the I value suppose is 1, then inside the string a will be stored. If the value of I is 2, then 2 will be stored. If the value of I is 3, then 3 c will be stored. Okay. So that is how I will be storing the string along with the value 0. Okay. Then we will check that if the particular state I comma j is not calculated, if the v of I j dot second is not equal to -1. So if it is already calculated, in that case I'll not calculate it again because that will take a lot of time, and we will memorize it and simply return the value that we have already calculated. Otherwise we'll mark our minimum as int maximum, and then we'll make a null string because we will be building up our string. So we'll try to partition at every index starting from I till k is less equal to j minus this thing, till as we used to do in this part, like j minus I, so till j minus 1 here, till j minus 1 we used to do it, right? So here also we will do it till this part only. Till this part only we will do, and we will first of all get the left part. This will be our left part calculated, okay? And we will also get our right part calculated here. And once we have our left and right part calculated, so we will calculate the current value. So current value is nothing but the left part, because left dot second will give me the value. So left dot second plus the right dot second, the right pair dot second plus the computation plus this part. As I mentioned, if we have AB and CD. So if we get suppose the left part, okay, if you have the left part and the right part, so we'll add those values. Okay, they are stored in the second, so dot second we can write dot second, and if the dimensions are of this kind, like in this kind, so in this case if it is 1 cross 2 and suppose 2 cross 3, so plus we'll add 1 into 2 into 3. That is nothing but array of p of I minus 1 into p of j into p.
Then Hello, everyone. Azimba. Aglovana Dima. Ada Sharam. Ada Param. ज्यादा वो तड़पते जो कि दो चेहरे ही लगते System, system, system. सेम मैट्रिक्स चेन मल्टीप्लिकेशन जैसा ही है. Pam 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 pam. चतुरा चतुरा इश्क गुलाबी बादलों का चुरा है ओ ये इश्क मेरी तो सनम तेरा दिल से इश्क है कि पूरा है तेरी यादें तेरी सादगी हमें छोड़ा से आग नजर नहीं हमें आपके इश्कों में ढल लाई होंगे मेरे गुजर आज से लाई होंगे तेरे गुजर आज से कुछ भी बस na 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 Four into three into five, so three into two into five. Okay. Three into five into two into three. What? 嗯。
Hi everyone, welcome to my YouTube channel. I hope you are doing well. So today's problem of the day on the Reach for Geeks platform is maximum prepared product. So we'll be discussing about this problem in this video. Well, before proceeding further, make sure to subscribe my channel if you haven't done so, and make sure to join our Telegram group as well. The link for the Telegram group is given in the description itself. So do join. So the problem says given an array ARR of size n, we have to find the maximum triplet product in the array. Okay, so let's understand the same with the help of an example. Here we do have n equal to 4, that is the size of the array, and the array contains 1, 2, 3, 5. Now what we have to determine? We have to determine the maximum triplet product. Okay, so here if we are taking 5, 3, 2, so these are the triplets we are taking, then the product is 30, which is the maximum possible triplet product in the array. So hence we are getting the output as 30. Next example, let's have a look on that as well. So here we are having n equal to 7 and the array contains -3 minus 5 1083 minus 2. So the output here we are getting is 120, right? So see, if we are taking the triplets -3 -5 and 8 and we are multiplying, so we are getting 120, which is the maximum possible triplet product in the array. Now what we have to do is we have to complete the function max triplet product, which takes an integer n and an array err and returns the maximum triplet product in the array. Okay, so I hope you are clear with the problem statement, right? Even we discussed the examples as well, so I think the problem statement should be clear. Now comes like the approach part, right? So how we
So, hello everyone, my name is Akshay. Let's start with details with this week of the 140. So let us read what the question is about and we can think the different approaches and code we can think and code of, right? So what's the name of the question is maximum triplet product. So immediate evaluation. There is a one-line question that is given an array of size and the task is to find the maximum triplet product in the array. Okay, so we have to choose such three numbers that the product of it will be maximum if you have chosen the triplet, right? Regarding the rest of the numbers. So if you can see for the first input case, the three numbers chosen 5, 3 and 2, which is of the 30. So it is very clear that if the elements are positive, then you just have to
Okay, so hi guys, we are live again. Yesterday, not yesterday, but whenever I was missing these these problem today. I was not posting them on YouTube, so today I am solving the POTD of yesterday, that is of 10th March.
Jupiter tayo. Oh. Oh. Lead code 313. Yeah, lead code 313.
So before starting the video, I'd love to tell you that I'll be taking a session on career guidance, which will be an interactive session on this Saturday at 10 p.m. So you can check out the link in the description and make sure you enroll for it. On this session, I'll be sharing you a Google Meet link where you can choose number written on it. Like this first balloon has a number 3 written on it, the second balloon has a number 1 written on it, the third balloon has a number 5 written on it, and the fourth balloon has a number 8 written on it. Okay, so you have to burst them. Now imagine if I'm bursting 5, then the number of coins that you will get will be the left side of it, he himself, and the right side of it. So it is 40 coins is what you'll get if you burst out 5. 40 coins is what you'll get if you burst out 5. So the question states you have to burst the balloons in any order you wish. You can burst 5, then you can burst 8, then you can burst 1, then you can burst 3. Or you can go 3, then 5, then 8, then 1. You can follow any order. And in following the order, you will be getting some coins. Because every time you burst a balloon, you get some coins. So the summation of the coins, so the summation of those coins should be maximum is the question. For an example, if I decide that the first balloon that I'll burst is 3, then what will be the number of coins that it will be adding? The left of 3 is 1, the right of 3 is 1, and he himself is 3. So the number of coins added will be 3. Okay, after bursting this, you're left with 1, 5, and 8. Now imagine I say, hey listen, can you please burst out 1? Can you please burst 1? Now remember, previously 1 had a 3 on the left, but since you bursted that balloon out, for this one there is no 1 on the left, there is no 1 on the left. So since there is no 1, you take 1 itself, and on the right it is a 5, so you take 5. So the total will be 5. Now I decide after this you have 5, 8. Now I'm deciding that, hey listen, let's burst out 5. So if you're bursting out 5, you'll get 1 on the left, 5 himself, and 8 on the right. 1 on the left, 5 itself, 8 on the right. So I guess this will be 40. Right after this, you'll be left out with 8. So if you're left out with 8, the left has nothing. Like if you're bursting 8, he himself, and the right has nothing, which is this. So if you add this up, I think you will get 56. So the total number of coins that you get if you're bursting out first 3, then 1, then 5, then 8, the total number of coins that you'll get is 56. So the order that we took was very simple. First 3, then 1, then 5, then 8. What if I say, at first, let's try bursting out 1. At first, let's try bursting out 1. So if I try bursting out 1, it will be giving me 3 on the left, 1 himself, and 5 on the right, which is a summation of 15. Right after this, we will have 3, 5, 8, right? So after this, what I'll do is I'll try to burst out 5. So I burst out 5, 5 himself. On the left, we have 3. On the right, we have 8. So the summation total will be 120. Right after this, we have a 3, 8. Now I decide that, hey, listen, I'm going to burst out 3. So if I'm bursting out 3, 1 on the left, 3 himself, and 8, which gives me 24. Right after this, I have 8, which means 1 on the left, 8 himself, 1 on the right, which is 8. So if I summarize this entire stuff, you get 120 plus something like, I think you'll get 167. Yeah, if you summarize this up, you'll get 167. This is the summation of coins that you're getting. And the question stated, you have to maximize it. So 167 is the maximum coins that you can get if you follow the order of at first 153. Like if you follow 1, 5, if you're following 1, 5, 3, 8, the maximum coins that you'll get is 167. You can follow various other ways, but you will see that 167 is the maximum that you can obtain, right? So pretty much that is the question. So how do you solve this question, or how do you approach this question? If I again write down the example, it was very straightforward. 3, 1, 5, 8. So do you see a pattern to this question? Because is this somewhere related to the partition or the MCM question that we did? By the way, if you have not seen the MCM DP and the previous DP50, I'll recommend you to watch both these, because if you're not watching those both couple of videos, you'll not understand this. Okay, so please go back and watch out the MCM video as well as the DP50 and come back and watch this. Okay, so you have to follow an order, right? Like you can follow 3, then 1, then 5, then 8. You can follow an order like 1, then a 3, then a 5, then an 8. You can follow an order of 8, then a 1, then a 3, then a 5. So they can always be various set of orders, but you need to understand which will be the first you pick. So apparently this is the entire range of elements, right? Like 3, 1, 5, 8. Anyone among them can be the first. 3, 1, 5, 8. Anyone can be the first. Like you can burst out 3, you can burst out 1, you can burst out 5, you can burst out 8, you can burst out anyone. Okay, so can I say the range is this? Like if I take this is the starting point, this is the ending point. In between them, including 3 and 8 or 1 or 5, anyone can be a first element. Makes sense? So I can think it in the direction of MCM, because in the MCM, if you remember, there were matrices like A, B, C, D. Then we decided that we'll first take B and C, multiply. Then the resultant goes and gets multiplied with these couple of guys. That is what we did. So can I similarly say, if I consider this as an entire stuff, you decide which one is the first element. It can be 3, it can be 1, it can be 5, it can be 8. Then we start thinking of the second element. Then we start thinking of the third element. So we can follow that order. But can we? Can we? So let's understand, can we or can we not? By taking a simple example of B1, B2, like I'm just not taking numbers. I'm randomly writing balloons, okay? So it's like balloon 1 has this value, balloon 2 has this value, balloon 3 has this value, balloon 4 has this value, and so on. So imagine, I say you, okay, hey listen, let's burst this out. That is B4. If I'm bursting B4, what is the value that I add up to the answer? Can I say B3 into B4 into B5 is the coins that I'll get, like B4 himself, B3 on the left and B5 on the right? Is this the value that we will get? Definitely. So I will be left with this subportion to solve, right? So I'll be left with a subportion of B2, B3. This is a subproblem. I can call it as a subproblem. This subproblem has to be solved. And I'll also be left with another subproblem of B5, B6. So apparently, can I say this? Can I say this? What is? This is a value plus this subproblem we solved plus this subproblem we solved. Can I say this? The answer to this is no, I cannot. I cannot say this. Like I cannot just burst B4 and then solve this individually and then solve this individually, add up this answer, add up this answer. Will that work? The answer to this is no. Why will that not work? Let's understand. So I'll just erase this. I hope you got it. If I burst B4 at first, what will happen? Why solving them independently will not work is the main concept of this problem. So why this problem and this problem cannot be solved independently is the main concept of this problem. If you understand that, you are pretty much true. So imagine if you're bursting out B4, it is over, right? And what is the state? Like if you imagine the state, what is the state? The state after this will be B1, B2, B3, B5, B6, right? So just imagine if you have taken this as an individual subset, if you would have taken this as an individual subproblem and you would have bursted out B3. Apparently, right after this, right after B4, if you would have decided to burst out B3, who would have been the right guy of B3? B5. So can I say, even if I take this subproblem independently, this B3 depends, like B3 will be taking a dependency of B5, might. Or if I say, after B4, I decide to burst out B5, then also, like if I burst out B5, then right on the parallel, it has a B3 dependency and it has a B6 dependency. So imagine if you're bursting out B5, after this you will have B1, B2, B3, B6. So after this, if you decide to burst out B6, this B6 still has a dependency on B3. So you cannot just randomly decide that this is an individual subproblem. Because for DP to work, this has to be an individual subproblem. You should not be depending on the values of this. Understood? Now you might argue, but Strivo, if B6 is getting bursted, we just take the B3 as the left guy. No, that will not work. Imagine after bursting B5, you had B1, B2, B3, and B6, and you decided to burst out B3. So this B3 was dependent not on B5, rather on B6. So depending on who is getting bursted, B3 might be dependent on B5, B3 might be dependent on B6. So you cannot individually solve these couple of problems. You need to understand. You cannot individually solve these problems. You absolutely cannot. So a key point to notice is, if I start from the front, like we basically go across this, like if I just take you over here, we first had 1, then we had 5, then we had 3, then we had 8. So you cannot go in this direction. Instead of this, I will say, why can't I go in the opposite direction? We'll start thinking in the opposite direction, Like I will say, if there are 4 elements, who was the last guy? And the answer that I'll get is 8. And the answer that I'll get is 8. Then I'll say, who's the second last guy? And if this is a problem, I get this is the second last guy. After that, I'll say, who is the other guy? So it says 5. After that, I'll ask who's the other guy. It'll say this. Let's realize. Let's take this example only and understand, okay? 3, 1, 5, 8. So 3, 1, 5, 8, okay?
Parakeet AI is an AI job interview assistant that...
I say, like, 8 is the last guy to be bursted, okay? So as of now, we had this entire range. That has to be solved. Now to avoid complications, we know on the right of 8 there is no 1. We know on the left of 3 there is no 1. So what I'll do is, just to avoid complications, I'll add a 1 and I'll remove this. And I'll also add a 1 over on the right, and I'll remove this. But these are the numbers that I have to solve. Just to avoid complications, I added a 1 on the left and right. Okay. Now imagine this is the last guy to be solved. And initially this is the range that you're looking for. And I'm saying instead of now on this range deciding which is the first guy, I decide who is the last guy left. So if I decide who is the last guy left, can I say the cost will be 1 into 8 into 1 if 8 is the last guy. Just imagine if 8 is the last guy. Can I say the cost will be 1 into 8 into 1, which is if this is the range, the left of the range, the right of the range, and the number itself. So I've decided 8 is the last guy. So this is the coin that will be added. I'm just going in the reverse way. Okay. Right before this, if 8 is the last guy to be bursted, right before this, if you remember, there was 3 and 8, or what was it? Let's go back and watch 3 and 8. Yeah. So 3 and 8 was the guy, and I decided to burst out 3. So if 3 and 8, realize if 3 and 8 is remaining, that means you've bursted out 8, now you just have this much range. So I'll just erase out. You're going from the back, so you just have this much range. This has been bursted last. So now I'm saying you have a 3 that has to be bursted. You have a 3 that has to be bursted. So can I say for this 3, I definitely know, since I've bursted out before 8 will be the right guy to it. Because I'm going in the reverse direction. Just because 8 was here, in the next step I was able to burst 8. So I'm very much sure that 3 has the right guy 8 because all the others would have been bursted in these steps. Like 1 would have been bursted here, 5 would have been bursted here. So 3 definitely has the right guy as 8, which is, again, 3 itself. This is the range. On the left of range is 8, on the right of range is 8. So 1 into 8. On the left of is 1, on the right is 8. Perfect. So I bursted out 3. If you burst out 3, what are you left with? Can I say this is the range that you're left with? And in this previous, if you go across and you see you're just having 3, 5, 8, and in this you decide to burst out 5. Yes, in this you decide to burst out 5. Again, if you're deciding to burst out 5, you're definitely sure this is the range, right? And 5's right is 8. 5's this guy is 3. So you say 5 on the right is 8, and on this range on the left is 3. Again, why does this work? Because you know this guy will be bursted over here, right? So anyone who is not in the range would have been bursted in the next counter. Will be bursted in the next counter. So he exists over here. Since you're going in the opposite, you definitely know 3 and 8 exist because you're moving in the opposite fashion. So 3 and 8. Perfect. Now you go back. Now when you go back, you would have bursted 5. So the remaining range will be just 1. In order to burst 1, again you look on the left, which is 3, 1 itself, and on the right, which is 5. And you get a 15, you get a 120, you get a 24, you get a 8. You just moved in the opposite direction. And if you move in the opposite direction, the sub-problems will be independent. Like if I just take one more example of B1, B2, B3, B4, B5, and B6, right? So if I'm taking this example, if I just decide that, hey, listen, I'm going to burst out, for an example, B5. If I'm deciding to burst out B5 out of this range, then what I'll do is, if this is I, this is J, I know the left guy of this is A of I minus 1. I know the guy itself, imagine this is index, is A of index. Imagine the right guy is J plus 1. This is the coin that you will get if this guy is bursted right at the end. And this is a subproblem that has to be solved. So you will say, can you please solve the subproblem from here to here, which is I comma index minus 1? Because if this is index minus 1. And if this is index plus 1 to J. So these are the two subproblems which you can easily solve. Now, are these subproblems independent is my question. Obviously, they are independent. Yes, they are independent. Let me give you a proof. Are they independent or not? But like B1, B2, B3, B4, B5, and B6. Okay, I've taken this. Now imagine I'm saying B4 is the last guy to be executed, bursted rather. So B4, you're definitely sure the answer is 1 into B4 into 1, right? Right before the step, what will be the step? This is a subproblem, as I said, that you have to solve, or this is a subproblem that you have to solve, right? As I know, B4 was the last guy to be bursted. I definitely know B4 will exist over here, because only if B4 exists, then only in the next step it will get bursted. I repeat, B4 has to exist in the second last burst, and this is the last burst. B4 has to exist, because if B4 exists in the last burst, then only it can get bursted, right? So this is a problem that you're solving. So can I say, since this is lying over here and B4 exists, B4 will definitely be the guy who is on it, yes. And can I say, probably, it can be B1, B4 in the last step, probably, or it can be B2, B4 in the second last step, or it can be B3, B4 in the second last step, or B4, B5, or B4, B6. It can be either this or this or this or this or this. Anyone, no matter who it is. I am not dependent on these guys. Instead of that, for B5 or for B6, I'm just dependent on B4. Who is the guy to the left of it? I'm not dependent on this subproblem. Carefully see, so I've proved that it is not dependent on the left subproblem. Even if you're solving for B1, it is dependent on the range right guy, not on anyone over here. That is the proof. So I have easily proved you how this formula comes up. Again, I've given you why. Just the trick is there that you have to start from the bottom instead from the front. I must be thinking, but how will we think that we have to think from the bottom? Again, this will come with practice. When I did this problem at the first instance, it did not strike me. I had to go through a lot of blogs, forums. Then I understood that they're actually starting from the bottom, and then I realized that this is how we need to solve it. Okay, so not an issue if you're not getting the solution right at the go, and you have to watch this video. Okay.
Hey, still thinking about joining the 30-day Python using AI bootcamp by AI for Techies? So what if in 30 days you could...
So B1, B2, B3, B4, B5. Now, as I said, the first thing that you'll do is 1 and 1. So these are 5 balloons. Definitely N will be 5 balloons. And if I write in the next, it will be 0, 1, 2, 3, 4, 5. So can I say if N is 5, the first range that you're looking to solve, will be f of 1, 5. Or this is the range that you're looking to solve. This is the subproblem that you're looking to solve, right? Now in this range, like if B1, B2, B3, B4 is a range, and if I added 1 and 1, and this is the range. Can I say if this is I, this is J? Who can be the last guy if you're thinking of the last step? This guy can be your last guy. This guy can be your last guy. This guy can be your last guy. Or this guy can be your last guy. Anyone can be your last guy. And if anyone can be your last guy, can I say then it's very simple to write the recursion. Yeah, it's very simple. So since anyone can be the last guy, what I'll do is I'll just write the F and I know this will be I and this will be the j. So this is the subproblem that I'm solving. So if I've been given this, I'll try to solve it. Okay, and remember one thing: when will you stop? Even if we are having I and j over here, and this is a single subproblem, you still solve it. You still solve it. So if you're taking b2, then j will be moving here. So the subproblem will reduce. If there is a subproblem, you will solve it. But if there is no subproblem, then you stop. Like if at any moment I crosses j, if at any moment like you're just shrinking like this, and at any moment you've shrinked it enough so that there is no more subproblem. The least subproblem would be I equal to j when you're solving a single. But beyond this, there'll be no subproblem. If there is no subproblem, the coins that you'll get will be 0. If there is no subproblem, the coins that you'll get will be 0. Now can I say this can be the first guy, this can be the last guy, rather, last, anyone. So can I actually run a loop? Something like index will start from I and go till j. I can. So if you remember, the cost that we encountered was a of the right of range, the number itself whom we are assuming to burst, the right guy. So if we're bursting this guy, index, then we're taking I until index minus 1 and index plus 1 till j. Correct? So the two subproblems that we have to solve will be I, index minus 1, index plus 1, comma j. So can I say this will be the cost for every index? If we decide to burst this will be the cost. If we decide to burst this can be the first guy, this can be the last guy, rather, last, anyone. So can I actually run a loop? Something like index will start from I and go till j. I can. So if you remember, the cost that we encountered was a of the right of range, the number itself whom we are assuming to burst, the right guy. So if we're bursting this guy, index, then we're taking I until index minus 1 and index plus 1 till j. Correct? So the two subproblems that we have to solve will be I, index minus 1, index plus 1, comma j. So can I say this will be the cost for every index? If we decide to burst this will be the cost. If we decide to burst this will be the cost. If we decide to burst this will be the cost. So for every time the for loop runs, first time I'll get the cost to burst this, next I'll get the cost to burst this, next I'll get the cost to burst this, next I'll get the cost to burst this. So what will I be taking? I'll be taking the maximum, because that is what the question states. So probably I can keep a maximum is equal to an int mini. In Java it can be integer dot min value. Okay, and what I can do is I can say mini equal to minimum of mini and comma cost is what I can simply do. Once I've done this, the for loop ends. And can I return the mini? I can definitely return the mini. Yeah, I can definitely return the mini. This is how the recursion will be. Now, so what is the time complexity? Now we know that whenever we are applying recursion, it is going to be exponential in complexity. That's something we know. So what we need to do is, if there are overlapping subproblems, there will definitely be an overlapping subproblem. If we try to draw them to a tree, you will see that there are overlapping subproblems. And whenever there is an overlapping subproblem, we can memorize the solution and we can apply memoization in order to reduce the time complexity. Now, what is the shortcut that I've taught you? You go back and see in the recursion, what are the changing parameters? One is I. One is j, because they will be just changing. So what you do is you say, okay, let me write down the changing parameters. One is I, one is j. And what is the maximum value of I? Can I say it starts somewhere from 1 to n? So n is the maximum, so I can probably take it of a size n plus 1. What is the maximum value of j? Again, it can be from 1 to n. So again, I'll take n plus 1. So this is the dp array that it will create. Okay, and for every state ij, you will just plug in over here, dp of ij is equal to mini. That is what you're plugging in. Okay, and you just write one line over here. If that state has not been, like initially you can assign that with -1 and plunge that in over here and return dp of ij. This shuttle change will make your time complexity to be, now what are the number of states? 2, n, and n, I and j and n square, and there's an internal loop that you're running. If you carefully see the recursion, there's an internal loop for every state that you're running. So for every state, the total number of states are n cross n. For every state you're running in, not exactly n, but somewhere near about a loop. So this can be roughly written as an n cube solution, whereas the space complexity will be n square, which you are using for the dp array, and an auxiliary stack space, yes, and an auxiliary stack space, which will be near about bgo of n, because if you're bursting out n balloons, it will take up a depth of n, because every time you select a balloon, balloon 1, balloon 2, balloon 3, so the depth will be bgo of n. So this is what the time complexity and the space complexity will be. And the next step, I will be coding this recursive solution, and then we will try to tabulate it. Now I'll return it back. So at the back I've inserted, and now I will be just doing an insert of right at the front. So if you use insert function.
शानदार ऑनलाइन एक्शन गेम वॉर थंडर आपके उबाऊ सप्ताह के दिनों को खत्म करने के लिए तैयार है। प्रसिद्ध जापानी बैटलशिप
Done. Next thing I'll do is I'll include hash include. It's important because okay, if it crosses.
Hey Molly, impressed by 500 days of there's such solid commitment and very motivating. I have also started my 45 days of code challenge 5 RSD sheet. Bye. Very good, भाई. जबरदस्त. जबरदस्त. सॉरी मैं थोड़ा चैट देखना भूल गया. माफ करें मुझे. What up? Come on. Come on, come on, come on. Huh. Code clues. मोहल्ले विच कुछ मकरी तेरा जाना सिन तेरे वांग वजदा ऑलमोस्ट सिमिलर ही है ये। किससे सिमिलर है? उससे मैट्रिक्स मल्टीप्लिकेशन। इसमें ऊपर से गया है और इसमें बस अपन नीचे से जाए। इसमें नीचे से जाए। आए तो मेरा आज no matching function at the city.
C equal to minimum, or the max equal to max C, comma cost. Once you've done this, what you just need to do is you just need to return max C.
We can do it. Yes, yes. Thank you, Ayush. गूगल का शीट भी हो गया क्या अपना? तो भाई now what I will do, हम वापस से नवंबर का शीट करेंगे क्योंकि क्वांटिटी वाली चीज नहीं, हमें पहुंचना है क्वालिटी पे। मैं 1000 प्रॉब्लम करने से अच्छा मैं 500 प्रॉब्लम 2 बार करूँ, तो इससे मुझे पैटर्न समझ आ गया। ठीक है, अभी तो 460 हुआ है। बस प्रॉब्लम Hello, Saurabh. Hi, 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 hi. My question था मैं भी DSA करना चाहता हूँ where should I start like I'm completely confused. First of all, get comfortable with programming language. Once you get comfortable with the programming language, then you can start any sheet like Striver's DSA sheet. Just go here and wait, it's loading. लोड क्यों हो रहा है हो रहा है ड्राइवर DSA शीट ये वाली शीट कर सकते हो अगर कंफर्टेबल हो जाए बाकी लैंग्वेज की कोई भी ये चलेगी प्लेलिस्ट कोई भी देख लो इतना अच्छा सी ये वाली शीट कर लो इसी इसमें यहाँ से एक एक उठाते जाओ करते जाओ सा एक दिन का टारगेट रखो जैसे लर्न द बेसिक्स वाले किया ये बोलो एक एक मॉड्यूल एक दिन ऐसा और इसमें बेसिक्स भी दे रखा है तो सही है सुंदर वो है excellent excellent yes pivot वाला I will surely try. Thank you very much. सब्सक्राइब करते जाना भाई प्लीज। सब 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 सही वहाँ पे है। व्यूअर्स लिया है सही को। So I will be joining you in this journey of your achievement. Best of luck. Thank you. कौन जिन्होंने था कोड क्लोज भी था जिन्होंने ये सीरीज स्टार्ट किया है 45 डेज ऑफ कोड चैलेंज तुम भी करो यार। उसने भी ड्राइवर का एचडी शीट स्टार्ट किया है ना। बढ़िया बात, बढ़िया ही बात है। क्विक सिलेक्ट वाला करा। पिवट आएगा केथ वाले फंक्शन कॉमा if ये मैंने सब के बराबर तो ब्रेक if also अगर यहाँ पे k minus I'm going to study now. Bye bye and thanks for the advice. See you soon. पढ़ाई करो, very good. पढ़ाई करो. See you. Thank you so much. यहाँ पे इनिशियलाइज करना है इसको। इक्वल टू नहीं आता। स्वैप करना। दोनों मिला है। Just Mierda.
Yamate, Yamate, Kamatri, Pran, Pai, Yamachi,
Nah, man.
ठीक है लिख देता हूँ।
Numbers make my head spin. How can I make this easy? Bruh, for
So let's continue with our greedy algorithms playlist. Before that, if you're welcome back to the channel, I hope you guys are doing extremely well. So the problem that we will be solving today is jump game. So you'll be given an array which will have integers. And the problem is stating, you'll be standing at the first element. And every element tells you how much maximum you can jump. For an example, if there is 2 over here, it means you can jump to this place or you can jump to this place. Not beyond it, not beyond 2 places. If there is 3, you can jump here, you can jump here, you can jump here. And the problem is asking you, if you're starting at the first element, can you reach the last element by jumping? Let's try it out. Over here, we have 2, right? Which means I can take a jump of 2, a maximum jump of 2. So if I go here, there is a jump of 1. So I'll go here and I cannot jump further, which means I cannot. But the question is stating maximum that you can take. I shall not jump the maximum. Instead, I'll jump by 1 place. And from here, I'll jump 3 places. So eventually, I can reach the end. Hence, true, possible. Okay, let's try out the other example. I'm standing over here. Okay? Can I reach the end? Let's try it out. If I start from here, I can either reach here, I can either reach here, I can either reach here. From 2, I can either reach here, I can either reach here. From 1, I can only reach here. You can try out all possible ways. I'm not able to cross 0. I am not able to cross 0. Forget about the last. I cannot cross 0. Thereby, I cannot reach. If I cannot reach, I'll be returning a cross. In this example, I can go here, I can go here. From 3, I can go here, from here, here. So eventually I can reach the last, right? It's important that you can cross the 0, right? So this is what you have to do. Given an array, you have to tell me if you can reach the end or not. How do I solve this problem? Let's take this example. You cannot cross 0. Thereby, it is not possible. Thereby, it is not possible. Let's change these examples and try one more example. I'll change this 3 to 4. Okay, now let's try out. From here, I can go here. From 2, I can go here, or I can go here. From 4, I can go here, 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 and here as well. Okay, from 1, I can go here. From 1, I can go here. From 0, I don't need to go anywhere. From 2, I can either go here, or I can either go here. So what I can see is, I can actually reach the end. If I take this pattern, sorry, my bad. If I take this pattern, and then this, I can actually reach the end. So it is typically possible. But tell me one thing, did you observe something? What if the arrays don't have a 0? What if the arrays don't have a 0? For that case, it'll always be able to reach the end. If the array just has positive integers, we'll keep jumping. There is no stopping us, right? And we will be able to reach the end for every possible scenario, right? Okay, so how do I solve this particular problem? It's going to be so simple. The only thing I have to see is, whenever I'm reaching an index, did someone reach me? Did someone reach me? For example, the 1 reached here, 2 reached here at max, 4 reached here. So when you are at 2, 4 can come here. So someone did touch you. Got it? That's what my intention would be. And if there was a 3 here, no one would have touched 2. That means you cannot reach there. Let's see how I can solve this. What we will do is we'll say, okay, what is the max index till which we have gone till now? Initially at 0, so you haven't gone anywhere. Okay, perfect. So we're standing at here, and we are at this place. So over here we have one place we can jump. So the max we can go is till 1, not beyond. Perfect. Next we come to this index. And for ease of understanding, I'll write down the index numbers. So we are at 2. From here, where can I go? 2 places more. I'm standing at 1. I can go to 2 places more, which makes it to the index 3. So the max I can go is to the index 3. Perfect. Next, I can go to 4. 4 means I'm standing at the second index. 2 plus 4 is 6. I can go a max of 6. Perfect. Next, standing at 3, I can go a 1, which is 4. No need to update max because I can still reach 6. Perfect. Next, I can go to this one, which is a 1. Standing at 4. 4 plus 1 is 5. I can still reach 6. So I don't care. I'm at 0. 5 plus 0 is 5. I can still reach 6. I don't care. Next, I have a 2. 6 plus 2 is 8. And you can stop over there. Because you have somehow crossed this. And if you have crossed this, that means you can definitely reach the index 7. So I'll just go back. I'll change the example so that you understand when is it not possible. Okay, so we stand over here. We stand over here, better, and I can erase this. I can convert this to 3. Now let's understand how this works out. So we're standing at 1. Okay, so the max that I can reach is the index 0 plus 1, which is 1. Okay, perfect. Next, I have a 2. So the max I can reach is 1 plus 2, which is 3. 1 plus 2 is 3. Perfect. Next, I can go to the next, which is 3. So I can go from 2 plus 3, which is 5. Okay, the next is 1. 3 plus 1 is 4. I don't care. Next is 4. I can go at max 1, so that's a 5. I don't care. I've already reached 5. Next I reach 5. 5 plus 0 is 5. I don't care. Next I reach 6. And this is where I say, hey, wait. The max you were able to reach was 5. How did you come here? As a person, you cannot arrive here. You cannot. Understood. Return false. Simple, right? So I have to write down the code. Again, I'll be writing down the pseudocode in case you want your language specific code. It's given below. Pseudocode, not any language specific code. So I'll be writing down the function. So you're typically given the array, correct? You can figure out the size of the array by array.size. Where do I start? I start at the 0th index, correct? And what I can do is I can go ahead and say I equal to 0, and I can get on till n minus 1. One thing I know is, hey, listen, if you haven't reached, if I is greater than max of index, if you haven't reached me, that means you cannot jump from here. So thereby you can straight away return false. Correct? Apart from it, can I say max index can always be updated to max index, comma I plus array of whatever jump is given to you. I can. At any moment, maybe you can just skip it. You can write if max index at any moment is greater than or equal to n minus 1, you can stop. And if this condition, remember, if this condition never happens, which means you're able to reach the last index, thereby you can straight away say, I start at the 0th index, correct? And what I can do is I can go ahead and say I equal to 0, and I can get on till n minus 1. One thing I know is, hey, listen, if you haven't reached, if I is greater than max of index, if you haven't reached me, that means you cannot jump from here. So thereby you can straight away return false. Correct? Apart from it, can I say max index can always be updated to max index, comma I plus array of whatever jump is given to you. I can. At any moment, maybe you can just skip it. You can write if max index at any moment is greater than or equal to n minus 1, you can stop. And if this condition, remember, if this condition never happens, which means you're able to reach the last index, thereby you can straight away say return false. Sorry, return to
To optimize, you can definitely insert an if condition. In case during the journey you are able to reach, you can put an if condition over here. That will be it. What is the time complexity? Bgo of n. What is the space complexity? Bgo of 1. That's it. This is the most optimal solution. Again, I was greedy. I tried to jump the maximum and see if I'm able to reach the end or not. Simple sorted greedy algorithm. The catch over here is 0. If you're able to cross 0, you will be able to reach. And if there are no zeros, you will always be able to reach. That's the catch. And please tell these edge cases to the interviewer. They'll be more than happy. So this will be it for this one. So if you're still now watching and if you've understood everything, please do consider giving us a like, and if you're new to our channel, do consider subscribing to us as well. With this, I'll be wrapping up this video. Let's finish some of the video. Okay.
Whenever your heart is broke.
Maybe I can take a 2 jump, or maybe I can take a 3 jump.
What's up? You seem pumped up today.
Yeah, I have joined this new quant team as an ML expert.
Wait, you mean ML? Machine learning? Is it the future?
Yeah, have you noticed how AI, machine learning...
That you will definitely reach the end. In the part 1, the question was, will you reach the end? Over here, the question is, tell me the minimum jumps that you will take to reach the end. Got it? So what will be the answer for this particular test case? What I can do is from here, I can jump till here, which is a jump, single jump. From 1, I can take one more jump, which is another jump. From 4, I can directly jump to the last. So I'm taking 3 jumps, right? So I've taken 3 jumps, and this is going to be the answer. Minimum jumps. You can try out all the possibilities, and 3 is the minimum answer that you'll get. Now, if this problem comes up in an interview, what is the extreme range solution that you can think of? I know one thing. Starting at the 0th index. And there are 2 possible ways. One is this, one is this. From here, there are 3 possible ways. So every index has different ways. Can I try out all ways? Yes, I can try out all ways, and then can I pick the minimum of all of them? I can, right? So what I will do is I'll just take a smaller example. Let's take a smaller example, which is 2, 3, 1, 1, 4. Can I say, I can start at the 0th index. I'll be trying out all possible ways, and you know how to do it. Recursion playlist, remember? I'll be starting with the 0th index, and the number of jumps that I have taken as of now is 0. What I can do is, I know I'm allowed to take at max of 2 jumps. So I'll take a jump of 1, I'll reach the index 1, and that will be 1 jump. Or I'll take 2 jumps, I'll reach the index 2, and that will be 2 jumps. From here, there's 3 given to you. So maybe I can take 1 jump, maybe I can take a 2 jump, or maybe I can take a 3 jump. So if I take a 1 jump, I'll reach 2, correct? If I take, that'll be 2 jumps. If I take 2 jumps, I'll reach 3. That'll be 2 jumps. If I take 3, I'll be reaching the 4th index, and that'll be 2 jumps. And if you carefully see, this is one of the ways, this is one of the ways, this is one of the ways. And this is going to tell you, hey, you reached your end. So you're going to take minimum of this, and minimum of this. So eventually, it will be returning you 2 because you've taken 2 jumps. So you'll get your answer as 2 for this particular test case. You'll try out all possible ways. Plain recursion. Very simple recursion. Can I super quickly write down the recursive code? Maybe this. So I'll write, okay, function, maybe I can take an index. I can take the jumps. And this will be called with f of 0, 0, with the array, obviously. You know what is the base case? What is the end case? And one thing for sure, the end case is A. If at any moment the index is greater than n minus 1, that means I've either reached or crossed over. And if that is the case, I'll be like, hey, can you return? Now this is very important. Can you return? What will I return? I'll be returning the number of jumps, right? Perfect. Done. What's the next thing? I'll be like, okay, how many jumps can I take? I can start from 1. I know for sure I can start from 1. And I can go ahead till array of index. Those many jumps I can take. I'll have to take a minimum of all of them. So maybe I can keep a mini equal to something as, I need a mini answer, right? I'll keep it as int max. Perfect. And what I'll do is mini equal to minimum of mini, right? Comma, what I can write is function of standing at index. If I take the jump I, I'll reach index plus I, and the jumps will be added by plus 1. Perfect. So I'll take all the jumps, and whatever is the minimum, I will straight away return it. Done and dusted. That's it. Just to make sure you don't start with 0. Then it will go to the same index. There's no point in jumping to the same index. So this will be the recursive code. And if I have to write down the time complexity, this will be exponential in nature. You are going for n indexes, so n to the power n, assuming all the jumps are till n or something near about that. So it can go exponential in nature. Whatever the space complexity, I'll be using auxiliary stack space of Bgo of n. Correct. Now, what you can do is, this is exponential. You can optimize this. Yes, you can optimize this. How can you optimize this? Again, if you haven't seen the dynamic programming playlist, don't watch this dynamic programming portion. If you know dynamic programming, you can watch it. So for the people who have seen my dynamic programming, you know how to optimize an exponential state to a quadratic state. You know it. There are 2 variables that are changing. One is index, the other one is jumps. So what you can do is, instead of returning mini, you can technically declare a dp of n, correct? And you can say dp of index and jumps equal to mini. And over here, you can say, hey, if, not here. Over here, you can say, hey, if dp of this state has been visited previously, make sure initially your -1 has been visited previously, you can return dp of index jumps. Quite simple. So if you do this mini, you can technically declare a dp of n, correct? And you can say dp of index and jumps equal to mini. And over here, you can say, hey, if, not here. Over here, you can say, hey, if dp of this state has been visited previously, make sure initially your -1 has been visited previously, you can return dp of index jumps. Quite simple. So if you do this, the solution will be converted into a Bgo of n square solution, with a space complexity of Bgo of n square. Now this is what it will be converted into. Okay, perfect. I think we have pretty much understood. We have understood it, right? What's the next thing? Again, you can optimize this. You can optimize the space, go into space optimization. I leave that. This is not a DP problem. So I'll leave that. In case you've seen my DP playlist, you know how to solve it. Obviously, the interviewer will not be happy with the Bgo of n square, and I'll ask you to optimize it. So I'm looking forward to optimize n square. That means I'll have to go somewhere around Bgo of n, correct? Okay, how should I think a Bgo of n solution? That's a big question, right? What was I doing in the recursion? I was trying out all possibilities, then I took the minimum. Can I try out all possibilities? Maybe I can. I know at 0's jump, I'm standing in the first element, right? If I take this jump of 2, what are the possibilities I can go to? I can go to here, I can go to here.
Parakeet AI is an AI job interview assistant that gives you answers and solutions to every coding problem on your job interview.
That means I can take a jump of one, and I can reach either 3 or either 1, right? Okay. So I'll keep it in mind that this portion can be reached. Remember this? I'm dealing with ranges. Instead of doing the recursion for this, I'm carrying the range. I'm saying jump 1 means this much. This one can be reached in jump 1. Already done a similar problem, which is valid balance as a string. Go back and watch it. We optimize the recursion in 2 ways. Okay, so I'm saying instead of recursion, I can reach from here to here. Perfect. If I take a jump from here, I can either reach here, which is going to take me like 2 jumps. There's no point because I can reach this place in 1 jump. So I'll not do this because recursion means minimum. I'll do the minimum. Okay. Then I can reach here or I can reach here. So I can reach both the places. So that means the farthest I can reach is this. Okay. For this, the farthest I can reach is here. Thereby, I'll be like, this is the next range I can reach by taking 2 jumps. In range concept, I tried jumping from here, and the max I could do is this range. So if someone is asking you, what is the minimum jumps taken till 4? They're like 2 jumps. Straight away know it. Okay. From 4, where can you go? You can go here, which is going to take you 1 jump. So 1 more jump. 3 jumps in total because till 4 you took 2. You want to take 3 jumps till here? No. So I'll go here. Can you go here? Yes, in 3 jumps you can go here. Can you go here? In 3 jumps, yes. Can you go here? In 3 jumps, yes. Because till here it is 2. So I know I can reach till the last. Okay. For this one, I can reach here. So I know the max I can reach is here. So from here to here, I can reach in 3rd jump. That is going to be the last range. Once you reach the last, you stop. And what is the last range reachable at? It's reachable at 3 jumps. So what I did was I didn't create individual recursive calls. I carried a range for it. It's like I carried a range. Let's check out the code. It's going to be super easy. I'll write a very simple code over. We tell me the initial jumps. You know it, right? Initial jumps is 0. Tell me the initial range, this much. So maybe you can carry a L and R, which is initially at the 0th index. Okay, from here, when I jump, till here. What is the next range? The next range is this. So where will L go? Please focus. L will go to 1 place ahead of R. Where will R go? To the farthest that I can jump. Perfect. And with this jump, what will be the value of jumps? 1. So if I take 1 jump, I will reach this range. Done and dusted. What is the next one? For this 3, the farthest I can go is this much. For this one, the farthest I can go is this much. So from this range, the farthest I can go is till here. So what I'll do is I'll update L and R. Again, focus. L will go 1 place ahead of R. R will go to the farthest. Done. What will happen to the range? What will happen to the jumps rather? 2. Okay. Standing at this place. Again, 4 can go how much? You can go here. Farthest. Okay. 1 can go here. The farthest you can go from this range is till this place. So what I'll do is first update L, which is going to be 1 plus of R, then update R, which is going to be this. And the moment R reaches or crosses n minus 1th index, I'll update the jump for this one. Once it crosses the n minus 1th index, the jumps is going to be your answer. Got it? Very simple. The code is going to be super duper simple. I'm going to write a function. I have the array. Maybe given the size of the array as well. Or if not, you can compute the size of the array. What do I need? Okay, initially, I'm doing 0 jumps. I'm having L initially at 0, R initially at 0. So I'm going to try out everything now. Okay, I can try out till my range, and the right of range should be lesser than n minus 1. If it exceeds, goes at n minus 1 or beyond n minus 1, I stop. Okay, at this time, what do I do? For this range, I find out what is the farthest I can go. Okay, so I'm going to go to the farthest rate. Then we can call it farthest equal to 0 because I'm trying to get the farthest. Now what I can do is, I can start from index. What is my range? It's from L to R, right? It's from L to R. So what I will do is, I'll start traversing from L to R, okay? And I know one thing, if I'm standing at I can go till the jump allowed, and I need to see what's the farthest I can go. So I'll be like, okay, what's the farthest? It's going to be max of this one, comma, farthest. Very simple. Once this is done, once you traverse for all elements in that range, you know the new range. And what is going to be the new range? L is going to be at R plus 1, right after that element, and R will be the farthest. And please make sure you update jumps. So for the same time, you can do jumps equal to jumps plus 1. And you can end the while loop. And once you've ended the while loop, what you can do is, you can straight away return the number of jumps it ended up taking. And that's it. That's pretty much it. Done and dusted. What is the time complexity? On a very naked eye, it might look like while loop into a for loop, big O of n square. No. What did you do? First you traversed 2, then you traversed 3, 1, then you traversed 4, 1, and eventually you reached. So what you're doing at the end of the day is traversing each element one by one. This while loop is just to check, did you reach? So eventually, the time complexity is big O of n, which is linear in nature, and the space complexity is big O of 1. That's it. That's it. So let's see. I thought of a recursive solution. And instead of doing the recursive tree, it kept a range. It converted the recursive solution into a range-based solution, right? And this is how you can do it. Why is it under greedy algorithms? The reason being, I'm trying to reach the farthest.
हेलो 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 हेलो। अरे यार मैं आदत से मजबूर हूँ। तुमको समझना है क्या ये वाला? भाई लोग, समझना है क्या ये वाला? जल्दी बताओ जल्दी बताओ जल्दी बताओ। आज का आखिरी सवाल है ये मेरा। जल्दी बताओ जल्दी बताओ जल्दी बताओ। हम्म। ठीक है फिर। सॉरी यार मैं थोड़ा इसमें ये हो जाता हूँ, गुम हो जाता हूँ। फिर चैट देखना भूल जाता हूँ, है ना? मैंने माफ करी माँ ऐसे जन्म तेरा हो न पाया। ठीक है, चले फिर मिलते हैं कल। आपको यहीं पे मिलेंगे। मजा एंबियंस आपके साथ। 472 सवाल हो चुके हैं, हमारा 48 दिन, हमारे लास्ट 2 दिन बाकी है, लेकिन हमें एक दिन में ऑलमोस्ट 14 सवाल करने हैं। 14। ठीक है, ठीक है फिर सी यू एंड लव यूज। मिलते हैं कल। सब्सक्राइबर 496 हो गए आई थिंक, यस सर। 496 सब्सक्राइबर डन। नाइस। 4 सब्सक्राइबर 2 दिन बाकी है सिर्फ। ठीक है, ठीक है सी यू।